Lesson 99, Solving Rational Equations. So we solve rational equations by using cross products or the least common denominator. So here's an example. We have x divided by 5 equals 2x plus 4 divided by 2. When we use cross products, we just multiply across the equal sign. So we have 2x equals, then we have to do 5 times the quantity 2x plus 4. So we need to remember to distribute the 5 so that we get 10x plus 20. Now we're going to subtract 20 and subtract 2x from both sides. And we get, let's see, this goes away, negative 20 equals 8x. Then we're going to divide by 8. And we get negative, let's see, 5 halves. And that is what x equals. Now in example 2 is one that we were going to have to use the least common denominator. So we have 9 divided by 3x plus 15 divided by x equals 6. So we look at what the least common denominator would be, and that would be 3x. So we're going to multiply 3x times all of the terms in, whoops, I forgot to put 3x there, in the equation. So I have 3x times 15 divided by x equals 3x times 6. So then we can simplify. These cancel. We get 9 plus the x cancels. 3 times 15 is 45 equals 18x. And we combine like terms. 9 plus 45 is 54. And we divide by 18. And x equals 3. We also just want to make sure that x doesn't equal 0 because it will make the denominator 0 in the beginning. So it's not 0, so we're fine. Here's another one, example 3. 12 divided by x plus 15 divided by x plus 1 equals 72 divided by 3x. You have to find the least common denominator first. We need a 3, we need an x, and we need an x plus 1. So we're going to multiply the entire equation by 3x times x plus 1. So in the first term, the x is going to cancel, and we're left with the x's cancel. So you're left with 3 times 12, which is 36, and then times x plus 1. In the second one, the x plus 1 cancels, so we have 15 times 3x, which is 45x equals. Here the 3x cancels, and we're left with 72 times x plus 1. Then we use the distributive property. We have 36x plus 36. You have to remember to times 36 by both of those. Plus 45x equals 72x plus 72. So when I add 36x and 45x, I get 81x plus 36 equals 72. X plus 72. So I'm going to subtract 72x and I'm going to subtract 36 from both sides. That way those go away. 81 minus 72 is 9x. 72 minus 36 is 36. Divide by 9. And x equals 4. And that would be the answer for that rational equation. Now sometimes when you solve, there is a solution that will not work in the original equation. Those are called extraneous solutions. An extraneous solution is a solution that does not satisfy the original equation. In other words, it's going to make the denominator equal to 0, which we all know is a problem. You can't have a 0 denominator. So here's an example where you may have an extraneous solution. 3x minus 1 divided by x plus 3 equals 2x minus 4 divided by x minus 2. So because there's an equal sign here and this is a proportion, we're just going to cross multiply and we get 3x minus 1 times x minus 2. Now these are binomials and they need to be in parentheses so we can remember to use FOIL on them. We might get a middle term. So this one is, our first is 3x squared. Outside is 6x. Inside is negative x. Oh wait, outside's a negative 6x. This should be a negative. And then the last is a positive 2. Equals, so the first here is 2x squared. Outside is a negative 4x. Inside is a plus 6x, and the last is a minus 12. So let's combine like terms. We have 3x squared minus 7x plus 2 equals 2x squared plus 2x minus 12. So what I'm going to do is get 0 on one side. So I'm going to subtract everything from this side. So I have minus 2x squared minus 2x plus 12. And then I'll do the same thing on the opposite side of the equal sign. These all go to 0. And we have 3x squared minus x squared is x squared. Negative 7x minus 2 is a minus 9x plus 14. Then I'm going to factor, and I'm looking for two numbers that multiply to get 14 and add to get negative 9. Let's see. Add to get negative 9. How about negative 7 and negative 2? Well, that works. So I have x minus 7, x minus 2 equals 0. By the 0 product property, I'm going to say x minus 7 has to equal 0, or x minus 2 equals 0. So I add 7 to both sides, I add 2 to both sides, and I get x equals 7 or x equals 2. Then we want to check to see if the solution makes a denominator equal to 0 in the original equation. Okay, so if I go, let's see, x equals 7. So in this beginning, the denominator 7 plus 3 is 10. 7 minus 2 is 5. So x equals 7 is okay. If I put in 2, I get 2 plus 3 is 5, which is not 0, so that's good. 2 minus 2 is 0. So here's a 0 in the denominator. We cannot have x equal to 2. So our final answer is just x equals 7. That's the end of the lesson.